Hello student, good morning. I am Dr.A.K Sinha. Today I will continue from the last class. Last class I have discussed up to the question number 156. I am discussing questions asked in competitive examination like medical and medical and engineering. Now I will continue from the question number 157. Now question I am reading. At STP, the density of CCl4 vapor in gram per liter will be nearest to first option 6.84, second 3.42, third 10.26, fourth 4.57. Again I am reading the question. At STP, the density of CCl4 vapor in gram per liter will be nearest to option 1 6.84, second option is 3.42, third 10.26, fourth 4.57. Now this question is asked in medical examination CBSE PMT. Okay, you can answer it easily. Okay, just think and answer. Its correct answer is 6.84. How? For that now I am telling you. Question you have to read carefully. At STP, the density of CCl4 vapor in gram per liter will be nearest to, means density, vapor density of CCl4 you have to calculate. Then now how will you do all the things? Then you know that 1 mole carbon tetrachloride means CCl4 vapor, that will be how much? 12 plus 4 into 35.5, that is equal to total 154, means molecular mass will be 154 gram, and 1 mole means 22.4 liter. Then density is equal to how much? Then density, you know, mass by volume. Then mass means here molecular mass 154 and its volume is 22.4 liter. Hence density is equal to mass by volume, means 154 divided by 22.4 gram per liter, means 6.875 gram per liter. Hence correct option will be first option 6.84. Okay, first option is correct. Now next question I am reading, question number 158. 1 liter of hard water contains 12 milligram magnesium ion, milli equivalent of washing soda required to remove its hardness is option 1 1, option 2 12.16, option 3 1 into 10 to the power minus 3, option 4 12.16 into 10 to the power minus 3. Again I am reading the question. 1 liter hard water contains 12.00 milligram magnesium ion, milli equivalent of washing soda, required to remove its hardness is. Again one more time I am telling question. 1 liter hard water contains 12 milligram magnesium Mg2 plus milli equivalent of washing soda, required to remove its hardness is, means how much milli equivalent of washing soda is required. Okay, then first option is 1, second option is 12.6, third option is 1 into 10 to the power minus 3, fourth option is 12.16 into 10 to the power minus 3. Just you think and answer. Okay, it is not difficult. Here you have to write the correct reaction. Okay, you have to, without reaction you can't answer. Then here now I am giving you a hint. Reaction first write that magnesium reaction between magnesium and sodium carbonate. Then actually sodium carbonate means washing soda. Then Mg plus Na2CO3, Mg2 plus Na2CO3, it gives MgCO3 plus 2Na, means it this is a neutralization reaction. Okay, by this only you can calculate magnesium will neutralize the sodium carbonate. Then here 1 gram equivalent neutralizes 1 gram equivalent of sodium carbonate. Both will neutralize each other. 1 gram magnesium will neutralize 1 gram equivalent sodium carbonate. Both are in equivalent. Then 1 gram equivalent of magnesium means 12 gram, and 12 gram means 12,000 milligram. 12 gram means 12,000 milligram, and 1 gram equivalent sodium carbonate means 1000 milli equivalent. 1 gram means 1000 milli. 1 gram equivalent means 1000 milli equivalent. Then now 12,000 milligram neutralizes 1000 milligram equivalent. Then 12 milligram magnesium will neutralize how much? Then 1 milli equivalent sodium carbonate. Correct? 12,000 milli equivalent milligram, 12,000 milligram magnesium requires 1000 milli equivalent of sodium carbonate. Then for 12 milligram how much? Then very simple way, it will be 1 milli equivalent sodium carbonate. Okay, 1 milli. Then correct answer will be what? Its correct answer that will be its correct answer will be option A, 1. Okay, option A will be correct, 1. Correct. Now next question I am telling you. Actually this this question was asked, this numerical was asked in medical examination. Okay, PMT. CBSE PMT. Now next question I am reading 159. 1 cc of N2O at NTP contains option 1 1.8 divided by 224 upside 10 to the power 22 atoms. Option B 6.02 divided by 22,400 into 10 to the power 23 molecules. Third option 1.32 divided by 224 into 10 to the power 23 electrons. All are upside, okay, not down. And fourth option is all the above. Then now just you think what should be the answer. Again one more time question I am reading. 1 cc of N2O at NTP contains option 1 1.8 divided by 224 upside 10 to the power 22 atoms. Second 6.02 divided by 22,400 upside into 10 to the power 23 molecules. Third option 1.32 divided by 224 upside into 10 to the power 23 electrons. Fourth option all the above. Now just to answer, think and answer. This question is also asked in medical examination. Okay, just to think. Its correct answer will be all the above. All the above. How? Then all three options you have to check. Okay. Then you know that 22,400 cc is equal to Avogadro number. Then for 1 cc how much? Avogadro number divided by 22,400 molecules. Okay. 1 cc N2O means Avogadro number divided by 22,400 molecules. Okay. Then N2O, how many atoms are there? Then total 3 atoms are there. N2O, 2N and 1O. Hence total number of atom will be, you have to multiply by 3. Means 3 into Avogadro number divided by 22,400. Okay, atoms in 1 cc. In 1 cc N2O will have 3 into 6.02 into 10 to the power 23 divided by 22,400 atoms. Now just to think how many electrons is possible here. Then in N2O how many electron is there? Just to think. N2O how many electrons are there? Then this nitrogen means how much? Nitrogen N2O, how many electrons are there? Then now N2O, that is the 14 plus 8. 14 plus 8 means 22. N2O. Oxygen has 8 electron. Atomic number is 8. And each nitrogen has 7. Then 7 plus 7, 14. 14 plus 8, 22. Hence, how many total electron will be there? Then you will get 6.02 into 10 to the power 23 divided by 22,400 into 22 electrons. Okay. Hence, it's a correct option. If you calculate for all, then you will find that you will get same result. Same result you will get in all cases. Correct? Hence, last option, all the above is correct. Okay. You have to calculate for 1 cc to this 22,400 cc means Avogadro number means 6.02 into 10 to the power 23. Then for 1 cc and 2, how many molecules are there? Easily you can calculate. That you can convert in atoms, and then you can convert in electrons. Correct? Then option, if you will compare with the given option, then you will find all three are possible. All three are possible. Means option D is correct. All the above. Okay. Now, next question I am going to discuss. That is a question number 160. When potassium permanganate is titrated, when potassium permanganate is titrated, when potassium permanganate is titrated against ferrous ammonium sulfate, the equivalent weight of potassium permanganate is: first option, molecular weight divided by 10. Second option, molecular weight divided by 5. Third option, molecular weight divided by 2. And fourth option, molecular weight. It's a very good question, and you can answer also. Again, I am reading one more time. When potassium permanganate is titrated against ferrous ammonium sulfate, the equivalent weight of potassium permanganate is: option 1, molecular weight divided by 10. Option 2, molecular weight divided by 5. Option 3, molecular weight divided by 2. Option 4th, molecular weight equal to molecular weight. Then it is a easy and direct answer you can give. This question is also asked in CPMT, medical examination. Think and answer. It is easy. Its correct answer is molecular weight divided by 5. Why divided by 5? Molecular weight divided by 5. Why? Then for that you should write the balanced equation reaction. Okay, means ferrous ammonium sulfate plus H2SO4. That reaction, if you will remember or if you will write, then 2FeSO4 NH4 whole 2 SO4 6H2O. This is a ferrous ammonium sulfate plus H2SO4 in presence of nascent oxygen. If you will write, then you will get product Fe2SO4 whole 3 plus 2NH4 whole 2 SO4 plus 13 H2O. Here what you will find that this oxygen, nascent oxygen is 16 part. Then 2 mole reacts with 2 mole FeSO4 reacts with 16 parts oxygen. Then for 1 part, 8 part you have to calculate. And also you can know that during the reaction you will find there are 5 electrons involved in this. 5 electrons are involved in this reaction. Then per electron you have to calculate. Per electron. Then obviously molecular weight divided by 5. Okay. And the answer is correct answer is molecular weight divided by 5. Option B, second option is correct. Okay. You should remember this reaction also, because this in how much electrons are involved, that also you should know, then it will be very easy. Correct? Then now I told you about this option B is a correct. Molecular weight divided by 5. Now next question, 161. Actually this question was also asked 160 in medical examination. Now 161, what I am going to do, that to read that question is also asked in medical examination. That is CBSE PMT. Now question I am reading. A metal oxide has the formula Z2O3. It can be reduced by hydrogen to give free metal and water. 0.1596 gram of the metal oxide requires 6 milligram of hydrogen for complete reduction. The atomic weight of the metal is: first option 27.9, second option 159.6, third option 79.8, fourth option 55.8. Now one more time I am reading the question. A metal oxide has the formula Z2O3. Z2O3. It can be reduced by hydrogen to give free metal and water. 0.1596 gram of the metal oxide requires 6 milligram of hydrogen for complete reduction. The atomic weight of the metal is: option A 27.9, option B 159.6, option C 79.8, option D 55.8. You keep pen and paper with you, it will be easy to solve. This question will take hardly 1 minute time. You can solve it. Just to think and then you answer. Okay? Think. Its correct answer is 55.8, option D, last option. 55.8. Okay. How? Now I am telling you. You read the question, then you can answer it. Okay. A metal oxide has the formula Z2O3. Z2O3. Okay. Then here Z2O3 means valency is 3. Metal valency is 3. Z2O3 means Z means metal. Metal has 3 valency. Then Z2O3 plus 3H2, you have to write balanced equation. Then you will write 2Z plus 3H2O. Z2O3 plus 3H2. Both will react according to the question. Then it will give 2Z plus 3H2O. Then now in question it is given 0.1596 gram of Z2O3 react with H2. Correct? 6 milligram. Correct? Then that you can call this 6 milligram, it reacts with 6 milligram. 6 milligram convert into gram by dividing 1000. it will become 0.006 gram, means 0.1596 gram of Z2O3 react with 0.006 gram H2. Then for 1 gram of H2, how much metal oxide is required? Then it will be 0.1596 divided by 0.006, means 26.6 gram. It will react with 26.6 gram. 1 gram hydrogen 1 gram hydrogen H2 react with how much Z2O3? Then 26.6 gram. Correct? Then equivalent weight of Z2O3. Now you are knowing 1 gram H2 reacts with how much Z2O3? 26.6. How did it come? Then according to question, it is 1.1596 divided by 0.006. It will come 26.6. Then the equivalent mass you calculated. Then equivalent mass of Z2O3, that is equal to equivalent weight of Z, equivalent weight of Z plus equivalent weight of O. Then equivalent weight of that is, you can write equivalent weight of Z and equivalent weight of O, means E plus 8. E plus 8. You don't know these things. E plus 8 means now you calculated now 26.8. Correct? Then for oxide, you are knowing for Z2O3 what is equivalent weight, that you are knowing. And you want to calculate equivalent, first we will calculate equivalent weight of metal. Equivalent weight of metal means Z you want to calculate. Z2O3 you are knowing now 26.6. Then 26.6 is equal to E plus 8. 8 you are knowing for oxygen, but for metal you don't know. Then easily you can calculate E plus 8 is equal to 26.6. Then E is equal to how much? 18.6. 18.6. After that you know that equivalent weight you are knowing. Then atomic weight easily you can calculate, because atomic weight of metal means Z, that is the equivalent weight of metal into valency. The valency you know it is 3. Valency is 3 and equivalent weight is 18.6. You calculated now. Then 18.6 into 3, that is the atomic weight. Atomic weight of metal, that is equal to equivalent weight of metal into its valency. Then now you are knowing 18.6. Just now you calculated. Then 18.6 into 3. It's correct answer. After multiplying you will get 55.8. 55.8. And the correct answer is 55.8. That is option D. Now next question I am reading. Question number 162. Ratio of Cp and Cv of a gas X is 1.4. The number of atoms of the gas X present in 11.2 liter of it at NTP will be. First option 6.02 into 10 to the power 23. Second option 1.2 into 10 to the power 23. Third option 3.01 into 10 to the power 23. Fourth option 2.01 into 10 to the power 23. One more time I am reading the question. ratio of Cp and Cv of a gas X is 1.4. Cp and Cv ratio is 1.4. The number of atoms of gas X present in 11.2 liter of it. How many atoms are present in 11.2 liter? That you have to calculate. Okay, that the number of atoms of the gas X present in 11.2 liter of it at NTP will be: first option 6.02 into 10 to the power 23. Second option 1.2 into 10 to the power 23. Third option 3.01 into 10 to the power 23. Fourth option 2.01 into 10 to the power 23. This question is also asked in CBSE PMT medical examination. Okay, it will take hardly 1 minute time. Just you read and think the question. Okay, quickly you can answer. It's a explanation I am telling you. First I will tell the explanation, then I will tell the answer. Okay, this ratio is given. Ratio is given Cp upon Cv is equal to 1.4. This shows that the gas is diatomic. This value 1.4 is there only for diatomic gas. Means Cp upon Cv is equal to 1.4. Shows that gas is diatomic. Then 11.2 liter at NTP means what? Half will be there, Avogadro number divided by 2. Correct? 22.4 liter is equal to 1 is equal to Avogadro number. Then it is given according to the question 11.2 liter. Then how many molecules will be there? Then Avogadro number divided by 2. Correct? Then now, because it is a diatomic, how many atoms will be there? In one molecule, 2 atoms are there. N2, anything, diatomic, any atom may be there. Okay. Then in one molecule, 2 atoms are there. Then you multiply by 2. You should multiply by 2. Then half Avogadro number divided by 2 into 2 upside. Because in one molecule, 2 atoms are there. Then 2 will be cancelled. Correct? 3 Avogadro number divided by 2 into 2. 2 will be cancelled, only Avogadro number. Means 6.02 into 10 to the power 23 atoms. Okay. And its correct answer will be option A. Correct? Option A. 6.02 into 10 to the power 23 atoms. Option A is correct. Okay. This question means you have to think and quickly you can solve. It will not take more than 1 minute time. Okay. Now next question I am telling you. Actually this question was asked in medical examination. Okay. This question what I discussed. Now one more question I want to discuss. What is the weight of oxygen required for the complete combustion of 2.8 kg of ethylene? Okay, again I am reading. What is the weight of oxygen required for the complete combustion of this 2.8 kg of ethylene, 2.8 kg kilogram of ethylene. First option is 2.8 kg. Second option is 6.4 kg. Third option is 9.6 kg. Fourth option is 96 kg. This question is also asked in medical examination, PMT, CBSE PMT. This question is actually easy. It will also require less than 1 minute time. Only thing is that you should know the reaction. Balance reaction you have to write. Then you have to simple calculation you have to do. Okay, means ethylene plus oxygen. That combustion reaction you have to write. Ethylene plus O2 you write, and then your calculation you can do. Then ethylene means C2H4 plus O2. Balanced equation you have to write. Then you know that it will provide CO2. It will give CO2 plus water. Then balanced equation you have to write C2H4 plus 3O2. It will give 2CO2 plus 2H2O. Correct? Then this is the balanced equation. Then C2H4 means what is the mass? Then C2H4 12 into 2, 24 plus 4, 28. 28 gram requires 96 gram oxygen. Correct? 3 into O2. Then O2 means 32. 32 into 3, 96. Then for 28 gram, 96 gram oxygen is required. You can convert it, both you can convert in kg. It means 28 kg required, 96 kg oxygen for complete combustion. Then for 1, then for 2.8 kg. It is given in question 2.8 kg how much oxygen is required. Then 28 kg required 96 kg oxygen. Then for 1, then for 2.8 kg. Then its correct answer will be 9.6 kg O2. 96 divided by 28 upside into 2.8. Correct? 28 kg required 96 kg oxygen. Then for 1, then for 2.8 according to the question. You will get 9.6 kg O2. 9.6, that is the option C. Option C is correct. Okay. Option C, 9.6 kg. Today I am stopping only here. Next class again I will continue. Thank you.